Hi. There are many different types of maps in the world. Most people are familiar with the typical road map, the one that helped you find where you were going back in the day before GPS and Google Maps or even MapQuest. Remember those? Few of us know that there are also political maps, economic maps, climate maps, and even a map depicting every country England has ever invaded. Oh yes, and spoiler alert, there were a lot of them. But did you know that NASA has something called fluorescence maps, which measure chlorophyll fluorescence light and offers a new view of the world's land plants? These maps are based on data collected from the spectrometer aboard a Japanese satellite and are the first to focus on land vegetation and to cover the entire globe. Chlorophyll fluorescence offers a more direct window into the inner workings of the photosynthetic machinery of plants from space. With chlorophyll fluorescence, we should be able to tell immediately if plants are under environmental stress before outward signs of browning or yellowing of leaves become visible. So said Elizabeth Middleton, a NASA Goddard-based biologist and a member of the team that created the maps. Joanna Joyner of the NASA Goddard Space Flight Center says humans can't see this light. Our eyes just aren't that sensitive. To see the light that's emitted from plants all over the world, we have to use scientific instruments that are placed on satellites. The quantum theory of quantum physics tells us about the coherence of light and proposes a dual nature of light, meaning that light can behave simultaneously as particles or waves. Light gives plants the energy they need to grow, but what happens if plants receive too much light? The answer is they glow. This neon glow is actually happening around us all the time, and it's the result of a cellular process where light from the sun is transformed and released as fluorescent light in a phenomenon called chlorophyll fluorescence. The light exits the plant cell and is released into the atmosphere, which is why NASA stated that their satellite instruments have given climate researchers an unexpected global view from space of a fluorescent glow from land chlorophyll. But would you believe me if I told you that bottle of olive oil on your kitchen counter also gives off a fluorescent glow that can be seen in space in much the same way as planet Earth glows? Or would you maybe start to question my IQ? It's not bad, by the way. It's true, folks. Olive oil, that rich substance we love to drizzle on our pasta or douse our salads with, emits a coherent light that makes it glow by fluorescence in the same way as our planet glows in space. Olive oil is unique among the majority of oils in that it is a product of a fruit rather than a seed. As such, it has a different constitution and naturally contains the green-coloured plant pigment chlorophyll, which is fluorescent. Though it may appear dull under regular light, hit a clear glass of olive oil with a green laser and the oil will glow red. And it's not just lasers that will get the olive oil to fluoresce, ultraviolet lamps will do the trick too and are accepted as an official method for the identification of the purity and grade of olive oil, according to the US Bureau of Standards. But before the existence of these specialised instruments that detect the fluorescent light emitted by plants on planet Earth from satellites in space, or the discovery of the quantum theory that explains how it all works, the Qur'an actually addressed this issue in a fascinating verse. In verse 35 of chapter 24, the Qur'an says, Allah, God, is the light of the heavens and the earth. The parable of his light is like a niche, pillar. In it is a lamp. The lamp is in a glass. The glass is like a brilliant planet lit from an olive tree, which is neither of the east, i.e. neither this tree gets sun rays only in the morning, nor of the west, i.e. nor does it get sun rays only in the afternoon. But it is exposed to the sun all day long. Its olive oil would almost glow forth of itself, though no fire touched it, light upon light. The verse likens the glow of the planet with the glow of the oil derived from olives, as both shine in the same way by fluorescence. Both are also dependent on the same physical phenomenon fueled by quantum physics, and both emit a coherent light. Coherence is one of the most important concepts in quantum physics and is strongly related to the ability of light to exhibit interference effects. A light field is called coherent, like the light from lasers, when there is a fixed phase relationship between the electric field values at different locations or at different times. Coherent light waves are waves with a constant phase difference. They will have the same frequency and wavelength. When two waves meet, they will interfere and superpose. This is called the quantum principle of superposition, and it's at the heart of quantum mechanics. If you look in the dictionary, the word superposition technically means one upon another. So when God says light upon light in the verse I mentioned just now, he's referring to superposition of light waves, one upon another. The fact that the Quran states that olive oil glows is in and of itself a miracle, as lasers and ultraviolet lamps now used to detect such a glow did not exist back then in any way, shape or form. Although planet is defined as a body that orbits a star, in our case the sun, and produces no light of its own, and although olive oil is dull under regular light, not only did the Quran inform us that they both glow on their own, but the Quran also asserts that they glow in a similar manner. What's more, the Quran refers to it as light upon light, long before the existence of the quantum theory of coherence, which now confirms the superposition of light waves. So the question remains, how could the Quran have known to use such a comprehensive analogy 1400 years ago? Was the Prophet Muhammad a quantum physicist? The answer could only be that the Prophet Muhammad had received divine revelation from God, the creator and originator of the universe.